So hi, welcome to another revision session for Cambridge National Award Certificate in Systems and Control Engineering, R113 Electronic Principles. And we're going to move on to capacitors. Now we finished with resistors in the last video, so we're going to just start introducing more and more components, and the capacitor is one of the first sort of new components that you need to deal with, because we use these in combination with resistors, as you're going to see a little bit later on. So what is a capacitor? A capacitor is basically the ones that you'll be familiar with are usually sort of little cylinders like this. They have a long leg and a short leg, and they have some sort of, the ones we've got have got a grey band on them, and they have a positive side and a negative side. So they are what's called a polar component, because they have to go into the circuit in the right way around. Okay, so they have a positive leg and a negative leg, and it has to go the right way in a circuit. Well, capacitor, the word capacitor comes from capacity. So we're talking about the ability to have a capacity for electricity, to actually store a charge. And by a charge we mean basically store some electricity, a little bit like a sort of mini battery. You can think of these as sort of like mini fast charging and discharging batteries. You'll have a good analogy. So let's have a look at how a capacitor works. So here I've got a voltage source, I've got some source of electricity, and you'll notice that the capacitor is a bit like a battery, or the cell, in that they've got two plates that are separated. Now this one's sort of positive, it's longer, and this one's shorter, therefore it's negative, and this represents a cell which generates or is the source of power. It doesn't generate, but it's the source of power for electricity for the circuit. Well, the capacitor is very similar in its layout. Effectively what's happening is, if we imagine we had a switch here and you closed that switch, the electrons, the negative charge would flow to here and the positive charge would flow to here. So effectively what happens here is that we end up with a charge, and positive and negative collection, if you will. So draw a few electrons on here. So here you'd have negative ions, an excess of electrons, and here you'd have positive ions, e.g. a load of, do you remember we talked about atoms, protons and neutrons, and we talked about having electrons negatively charged, positively charged, and if you had a hole you'd be positive, and if you had an extra electron you'd be negative. That's basically what we've got here. Now, capacitors measured in something called farads, named after a scientist, so we use a capital F, and 1 farad is equal to another scientist, just bear with me for a second, this gets a little bit confusing because 1 coulomb is basically, now we know what an amp is, an amp is a collection of electrons flowing around a circuit over a period of time. So coulomb is 1 amp per second, and 1 farad for 1 volt, bear with me here, basically if we take this thing here, on there we have 6.242 times 10 to the 18 positive charges for 1 farad, if you will. And on the bottom we would have 6.242 times 10 to the 18 negative charges. Bit like a battery, positive at one end, negative at the other. Okay, and just to give you an idea, if I start here and go 6 2, 4, 2, so 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We're talking a lot of electrons. So 1 farad is quite a useful charge of electricity. So that's how we activate a capacitor to store a charge of positives and negatives. If I open that switch again, break that circuit, for a brief period of time, okay, that capacitor will simply hold. There's nowhere for the electrons to go, there's no circuit to complete, and therefore it will hold that charge. If, however, we completed the circuit like so, let's have a lamp. This is the symbol for a lamp. What would happen is you've got all this positive ions and all these negatively charged electrons. Effectively, what's going to happen is now there's a way for the electrons to get to stabilize or to balance with or combine with to go neutral. And therefore, in passing through the lamp would give off some light. So we've got a capacitor charging up, filling up with electrons and protons, or positive ions and negative ions, and then we've got the capacitor discharging through a component, giving up some energy to create some sort of electrical or electronic effect, if you will. Something to notice, and you'll notice it here when you actually carry out this activity, you would see the following. As you switch the circuit closed, the lamp initially would come on, it would be very, very bright, and it would die off as the electrons pass through. As the electrons moved to the positive ions and the capacitor effectively discharged itself, that would happen quite rapidly, and you would see a sort of flash almost, and then the brightness would fade and fade and fade, and it's a bit like the electrons that they rush off here, pass through the lamp, but there's a few left over. You know, it's a bit like the emptying of a tube train. You know, massive people rush off, and then there's a few stragglers at the end. So you'll see an initial rush of electricity passing through the lamp, and then it will slowly fade off. And in fact, on this side, you'd see exactly the same thing. You would see a sort of rapid increase in charge. If you measured the charge here, you'd see this sort of sudden rapid increase over time, which eventually would sort of tail off. It would never quite get full. You never quite get all the electrons, all the charge on there, but it's sort of the initial charge would fill up, and then you'd sort of squeeze in the last few, and then when you discharge, so if we're right here charging, and here discharging, you can see it would rapidly fill up in time, put T across the bottom there, and then it would rapidly discharge and then sort of fade out. Where we introduce resistors later on, you'll see how resistors can be used to control how fast this happens. So rather than it just sort of happening instantly at the speed that the electrons travel, and then instantly again here, you would have a little bit more control, so we could delay the electron flow through here, so the lamp could be kept on for a little bit longer. So that's effectively the sort of the theory of the capacitors on that side. And now I want to look at some of the practicalities. I'm going to pose you a little question. So I'm going to come to the end of this video, I'm going to pose this question, and then we're going to come back to this setup, and we're going to look at the answer to the question that I posed. And my question is this. in series, I've got two capacitors. Like so. And this one is, for the sake of argument, 2 farads, and this one is 3 farads. The question would be, what is the total in farads? And I'm going to give you the same question. This is looking a lot like the resistor questions from earlier. Do you remember when we talked about resistors in series and resistors in parallel? Now there is some similarity, but there is a key difference, and this question is going to bring out that piece of knowledge. So let's move that across. A little poser for you for the end of this video. What do you think, how do you think you would solve those? And what we'll do is the next video we'll come back and we'll look at how you actually, the correct formula for working these out.